Sevengroup is a multidisciplinary collaboration of leading professionals dedicated to developing sustainable and regenerative solutions for the built environment. With 4 principal partners and affiliated partner companies, Sevengroup has contributed to the development of LEED and green building practices since 1995, with extensive expertise in green building rating systems, integrative design, regenerative development, energy and daylight modeling, materials, commissioning, communications, and visual story. Sevengroup has co-authored the Integrative Design Guide to Green Buildings. Learn more about Sevengroup at sevengroup.com. Site and habitat aspects of integrative design. John Becker, Sevengroup partner. Learning objectives. Develop deeper understanding of humans' role in nature. Experience whole system interrelationships. Introduce the concept of a participatory living systems approach. Work with levels of thought as an effective framework for working with living systems.
My name is John Becker. I'm a partner in Sevengroup. What we would like to talk about today is how site and habitat participate as elements within an integrated process. But this is solely an introduction, so really what we'll end up doing is just discussing the philosophy behind it more than actual implementation, to help create a foundation that you can then now apply to your work. The fundamental idea behind all of this is actually pretty simple, and that is that humans are nature. Other folks like to talk about it in terms of humans being a part of as opposed to apart from nature. If in fact we are part of a larger whole and one of the species that is inhabiting this planet, we're not separate from that planet in any way. In fact, every other system that comprises the whole living system is interrelated in a way that perhaps the role of the human might not be a whole lot different than being a bee pollinating a flower or being a bird eating a tick off the back of a rhinoceros. So I know that sounds a little esoteric, so let's unpack it a little. So why are we engaging in green buildings? Why are we engaging in an integrated process to do green buildings more effectively? In other words, what's our purpose? Now, we could unpack that for quite a while, but most often what we hear is that there are 5 environmental imperatives that we're trying to address: potable water, climate change, pollutants and toxins, resource consumption or depletion, and habitat health. But interestingly, whenever I ask folks in a room to talk about those 5, which one do you think comes up first? Almost always. Well, almost without exception, climate change. That's the one that seems to get the most press. Usually right after that, there are 3 more that come in pretty rapid succession. More often these days, I'm hearing potable water climb the ladder closer to the top. And of course, pollutants and toxins and resource depletion. Without exception, though, in I would say several hundred workshops that I've done where this question was asked, without exception, habitat health is last. I began to think about that, and I started to wonder why that is. And I think perhaps it's because we generally do not think of habitat as integral. And one way to help unpack that is, let's just pick habitat as one of the 5 imperatives. And just for a minute, pause and see if there are any of the other 4 to which it doesn't have a deep relationship. So one of the best ways that I have found to help unpack this is to use a little story about a project that colleagues of ours worked on, an amazing group called Biohabitats out of several cities in the US, but this particular project was just outside of Baltimore. It was a park, and in this park was a small little stream. And up at the top of the stream, there was going to be some additional development. In other words, increasing the amount of impervious surfaces, which of course increases the stormwater runoff. So almost all of us, in at least my generation and perhaps the next, have been conditioned into dealing with rainwater or stormwater with the very simple doctrine of collect, convey, and discharge. Collect it in a pipe, send it away. All right, well, this is why we have curbs, catch basins, and culverts, right? Well, this particular project, the engineering solution was to create a concrete trough which was designed to carry that additional stormwater off-site and eventually dump down into the Chesapeake Bay. But if we think about what that did, it actually contributed to all 5 of the environmental imperatives in a negative way. First of all, it was made of concrete, right? So you might not think that has a whole lot to do with energy, except for the fact that for every ton of cement that we create, a ton of CO2 is emitted into the atmosphere, hence dealing with climate change, which is really the issue behind energy, right? Well, it's one of the issues behind energy. There's also resource depletion, etc. Now, of course, the way you make cement is you mine raw limestone out of the earth, right? Throw it into a 2200 degree Fahrenheit kiln and melt it. When it cools, pulverize it, and you get this little powder to which you add water, and over 28 days with the heat of hydration with some sand and some gravel, now you have concrete, right? Well, eventually that concrete, particularly given the erosion of the water, is going to deteriorate, so every 10, 15 years you have to replace the concrete and go through that whole climate change / resource depletion component again, right? So we've talked a little bit about, actually you can see right there that there's pollutants and toxins, resource depletion, climate change, at least aspects of them. But what we're really talking about ostensibly here is water. So a way to get at water, if you had a glass of water in your hand, where did that water come from? Well, I asked my wife this question a few years ago, and she said it came out of the tap, right? I said, well, yeah. So we laugh about that now. In any case, most of the water we drink comes from underground aquifers. Not so much the surface water, because actually there's a much greater percentage of water that's below the surface than there is above. Well, where'd that water come from? Well, maybe it did come from those surface waters. Where'd that water come from? Well, simply stated, it came from rain. Bottom line is, we're all drinking rain. Okay, fair enough, right? So if rain falls on the roof of your house or your office, can you collect it and drink it? Well, as it turns out, you can't in most places in the world. And in fact, I've spent the last 12 or 15 years as a little hobby trying to find a Department of Health anywhere in the U.S. that would allow me to drink rain water that fell on my roof, and I could only find one. It's in the Pacific Northwest, which kind of makes sense. In any case, why can't we drink that water? You're saying, wait a minute, John, all we're drinking is rain, and now you're saying I can't drink the rain. Well, what's the difference between that rain and this rain? Well, pretty straightforward, right? The rain that falls on your roof is collecting an awful lot of contaminants that likely are on the surface of that roof or in the air by virtue of what? Well, predominantly burning the fossil fuels that it takes to generate energy that create particulates, acid rain, and so forth, right? So wait a minute. Now we understand why we can't drink this water. What's the difference between the water that falls on my roof and the water in this glass? Well, it's been filtered. Sometimes with mechanical systems, but I would suggest that's a way inefficient, costly, energy-consuming way of doing it, as opposed to how nature's been doing it for millions of years, which is filtering it through what? Well, soil. So you might remember from your junior high school geology classes that soil is composed of two things, right? You've got sand and organic material. Well, where did the organic material come from? Well, the organic material came from the roots of plants, etc., that actually are contributing organic material to that soil every year when bits of their roots die. So the way that happens is there are generated microorganisms that are in that soil that are in symbiotic relationship with the roots of the plants that are actually eating the contaminants that are in that water that's filtering through the soil that actually contribute to the health of the plant. Therefore, the plant now, as it grows, can now evapotranspirate that water by absorbing it through those roots and contribute that water back into the hydrological cycle so we have rain again. So what's really fascinating to me, very simply, is without healthy habitat, we have no water. In other words, without healthy habitat, we're all dead in 3 to 5 days. So it strikes me whenever I'm now asked about what are the 5 environmental imperatives, or why are we doing this? Healthy habitat may be the most important of all of them. Because if you think about it, there's absolutely nothing that we produce that isn't dependent upon healthy habitat. What's fascinating is Albert Einstein made this discovery in one of his 2 books that he wrote as prose. 2 great books he wrote late in his career. One is called The World as I See It, and the other is called Out of My Later Years. And they're really beautiful because they're just short essays. And in one of them he describes, I can't remember the name of this one, but he describes getting up in the morning and stepping into the shower, getting out of the shower and putting on his cotton robe, walking out into the kitchen, putting a piece of toast in the toaster, and while he's waiting for the toast to become toast, the bread to become toast, he thinks and he writes, I have just been interconnected with thousands of humans and thousands of species. And he begins to unpack that by identifying where did the water come from that produced that potable water for my shower, to the seeds for the cotton that was produced, that had to be planted by somebody, then harvested by somebody, cultivated by somebody, the organisms within the soil that actually produced that healthy plant to create that cotton, to transporting that cotton, to now taking that cotton and making it into thread, to now weaving the thread together to making the cloth and so forth, all the way to the planting of the wheat for the toast and so forth. I've learned almost everything that I know about water from a fellow by the name of Dr. Gerald Wilhelm, who is a principal with Conservation Design Forum. He's a botanist and hydrologist and also a Native American scholar, and CDF is located just outside of Chicago. Okay, so by virtue of the doctrine of collect, convey, and discharge, a concrete trough was created to send all this water down to the Chesapeake Bay that now gets clogged up a lot because there is debris in the way, so there's significant maintenance, which also has created a bit of a mosquito infestation. All around this concrete trough is actually turf grass, which my friend Dr. Gerald Wilhelm simply defines as, and he's from Chicago, so a drug-dependent rug sitting on a bed of clay, leaving the site bereft of water, generating a daily bowel movement in New Orleans. And the reason for that is because the nitrogen nutrients that are used to fertilize that turf grass actually are running off into that concrete trough, which is contributing to algae blooms and therefore eutrophication, because as the algae dies, it adds additional toxins to the water and kills basically all marine life, which you can see by looking at the dead zone at the Delta and Mississippi in New Orleans at the Mississippi River. So, in addition to that, we now take a 2-stroke internal combustion engine and 28 times a year chop off all the little photovoltaic panels that are the leaves that generate the root structure that's necessary to actually absorb the water and evapotranspirate it. But the shorter we make that grass, the shorter the roots. Therefore, we don't have any deep enough root structure to continually generate the biological material necessary for healthy habitat and microorganisms that are in symbiotic relationship with those roots on an annual basis. Hence, turf grass is sitting on a bed of clay, leaving the site bereft of water and nutrients, actually adding an overabundance of toxic nutrients into the system. On the other hand, what biohabitats did is they said, you know what? Using a different definition of integrative, which in one of our other sessions we unpack as to integrate is to heal, they said we could heal this place. So what they did, what the same place looked like 2.5 years later, and it is an absolutely beautiful, what appears to be pristine stream. So let's talk about how that works, because it's really critical to understand what they did. So all they did was operate on the principles of life. If I say the word sustainability, what does that mean to you? How would you define it? Well, in some ways, that term has become quite banalized. You'll ask 50 people to define it, and you might get 50 different answers. Well, I think the more important question is, what are we trying to sustain? And I would suggest what we're trying to sustain is life. Therefore, don't you think it might behoove us, at least I think it does, to understand the principles of nature, hence the principles of life. So all biohabitats did was understand that their role in being a human participating in the coevolutionary health of that place was actually to slow down the flow of the water, not get rid of it as fast as possible. And the reason for that is by putting things like rocks in the way to slow down the flow of the water. The nutrients, the healthy nutrients that are in that water, can now drop down into sand and gravel beds as opposed to sterile concrete, and therefore lodge in those little crevices in order to create nutrients to feed the fish and insect larvae that in turn feed larger fish, larger mammals, birds, etc., for example, that can now take those nutrients out of the stream and, in defiance of gravity, take them upstream and renutrient the system. In that way, once we begin to understand that we actually are participants in the health of habitat, we can now see ourselves potentially in the role of healers. So when we think about healthy habitat, we often limit our thinking to the site upon which our building is located. So one of the fundamental notions behind truly engaging an integrative process, which starts to move into a regenerative approach, is that our buildings are nested within a site. And that site is in turn nested within a larger site, which ultimately is nested within a watershed, or as our friend Carol Sanford likes to call it, a life shed. And that whatever we do with regard to the inhabiting of this particular site, hence the habitat, including us, has a significant potential impact, positively or negatively, whether we're conscious of it or not, so we might as well be conscious of it, of the larger system or site in which it is nested or its watershed. And as we've seen, just by discussing this one little example from the biohabitats stream, it's all just one system. Okay, from this example then, what we can see is, yes, it is one system. So that's a belief. Once we hold that belief, we can begin to engage all of our projects, I think, with a pretty powerful framework, one that we use often in our work, that we refer to as levels of thought, which we've really gotten from the work of Carol Sanford that she's been developing for quite a while, largely with her work with Charlie Crone, etc. So when you think about where you normally begin a project, most of us, I think, or at least I know I have for much of my professional life, started with a concept or started to formulate strategies or started to actually design. Think about how many projects begin with a design competition. Well, if we're really engaging habitat in a regenerative way, and I would invite you to also see our piece on regeneration, which talks about this. If we begin all the way down there, we're probably not aligning not only the entire team that is working on the project, but we're probably not aligning all of the other stakeholders, such as all the species that abide in that particular habitat, with an approach that will constantly build the capacity and capability of that system or that site, that particular set of habitat nested in a larger watershed, to remain and become and remain vital and viable indefinitely. As soon as we hold the belief, though, that it's all one system, now we can move down one level in our thinking to, okay, what's going to be our approach to working with that system, a philosophy. So philosophy might be understanding that every single organism or species within that system has a role to play in terms of participating in the health of that system and what it's trying to make manifest, particularly with regard to the role that that particular set of habitat or that particular site is playing in service to the larger systems in which it's nested. If everyone on the team aligns around, let's say, for example, that philosophy, now we can start to develop some principles. And principles that will guide our actions, our decisions, our choices, our behavior as we are working together on this particular project, which also helps us establish some ways of working with that particular piece of habitat. Because remember earlier in this discussion, we talked about every single place is particular. So let's pause here a minute. I live on about 30 acres in central Pennsylvania. It's a piece of property that I bought about 15 years ago and have eventually evolved it into a bit of a farm. But for the first 10 years or so I was living there, I really didn't have any idea who the land was, what it wanted to be, how it served the larger watershed. In short, I didn't know what at all to do with this land. So I invited my good friend, Dr. Gerald Wilhelm from Conservation Design Forum, to come and walk the land with me. And for 2.5 days, we did precisely that. And what Jerry was able to do was a flora and fauna inventory on a square meter basis. From this inventory of flora and fauna, what he was able to show me was that every single square meter of property on that entire 30 acres varied in its species from the adjacent square meter by about 30%. This is astonishing, or it was astonishing to me at the time. Think about the impact of that. Think about what that means. So I was pretty stunned by this, and I started to understand that, okay, every single place on the planet is entirely unique. Therefore, if we're working with any particular habitat in any particular place, we really need to understand its particularness, its uniqueness. What is it that it is trying to do in service to, it has a role to play in service to where it's nested in that particular watershed. So that's what I started to do with my farm. Well, interestingly, about a year later, I was presenting to some folks down in North Carolina. They were largely, the audience was largely composed of marine biologists. And I stated this about the square meter variance, and they said, oh, yeah. Guess what? We recently, in the last decade or so, have discovered that every cubic meter of the ocean varies in its inventory of species by about 30% from the adjacent cubic meter. Okay, so what that begins to tell us is there are some principles we can develop, such as ensuring that what we're really doing is paying attention to what's absolutely particular here. So what might work on my farm in Pennsylvania may have nothing to do with a site up in the Hudson Valley in New York, or a site down in Louisiana, or wherever. Furthermore, within the particular site, there are different sort of roles that each area plays. So for example, the 30 acres I have, the top 8 acres is wooded, and it receives runoff from the road that's up at the top, which now drains down into where I can begin to see, or thanks to Jerry and some additional research, I've discovered we're losing about 1 inch of topsoil every 9 years or so, which means that my role, our role, the human role potentially, is to begin to restore soil. So in this particular case, on my farm, my principle, one of my principles, is really simple. And that is every move I make needs to work on regenerating healthy soil. So now I have some cows and chickens on that particular piece of land, doing some forest management on the top acres. The cows are eating the grass, defecating. The chickens are scratching up the cow patties, adding biological material to the soil. And this is really fascinating. I started this 2.5 years ago, and what that pasture looks like now compared to the scrubland that it looked like 2.5 years ago is astonishing. So, if we jump back to this framework then, if we believe that what we're dealing with is one system, each piece of land is nested in larger and larger areas within that one system, and I would suggest the smallest one, of course, to engage is the watershed. Then we can begin from a series of philosophies, an approach about how to work with that system in a particular way based upon some principles, and we can develop principles about how to guide our responses that are derived from that approach and that belief. And now we can begin to engage a concept. So the concept then for my farm, as an example, is that I've discovered that there are 9 different sort of segments of the land, each of which has a specific job to do. And understanding how they relate to each other, I now have a concept for how I, as a human, can work with these systems that are nature, because I am nature, and help really build its capacity and capability over time through a series of strategies. And now I can design the thing. So after that, then there's 3 other levels, and that is have to keep testing it by building it, auditing it by seeing what the response is. So for example, testing the soil to see if the nutrients in that soil are continuing to head in the direction that's necessary to get at the acidity level that's necessary for the grass that needs to grow in order to support the cows and the chickens, in order to generate more soil. So that now I can evaluate those audits to be able to come back and maybe re-influence my concept strategies and design. So the understanding here, I think, once we understand that we're a part of nature, humans are nature, and we're dealing with one system, perhaps using this framework of levels of thought for every particular project can actually help us in terms of truly working in an integrative way with habitat.
Sevengroup is a multidisciplinary collaboration of leading professionals dedicated to developing sustainable and regenerative solutions for the built environment. With 4 principal partners and affiliated partner companies, Sevengroup has contributed to the development of LEED and green building practices since 1995, with extensive expertise in green building rating systems, integrative design, regenerative development, energy and daylight modeling, materials, commissioning, communications, and visual story. Sevengroup has co-authored the Integrative Design Guide to Green Buildings. Please visit the Sevengroup website for more information.